And welcome, everyone. Thank you so much for joining us for today's presentation of Breaking Down Analytics Silos, brought to you by Hydraulics and D-Zone. My name is Katie Bavoso, and I'll be your host today. And I'm excited to be joined shortly by two experts from Hydraulics. We have Catherine Johnson, Vice President of Engineering, and Coralie Suzure, Solutions Engineer. When record-breaking audiences tuned in to watch the 2025 Super Bowl, Fox faced a challenge of delivering a flawless streaming experience while handling petabytes of data across multiple CDNs in real time, a scale of observability once thought nearly impossible. Catherine will show us today how their approach not only enabled seamless visibility in that high-stakes moment, but also offers valuable lessons for any organization looking to move beyond siloed monitoring and toward more resilient, data-driven operations. Now, before we begin, a quick housekeeping reminder. Please use the chat feature that you see on your screen to comment during today's presentation. And of course, drop your questions in the Q&A section as they come up, and we'll address them in the Q&A live at the end. Now, please join me in welcoming Catherine and Coralie. Thank you both so much for being here, ladies. Why don't we have you kick us off by telling us a bit more about your backgrounds? Catherine, can you get us started?
Sure. I have a background in data and observability. That's what I've been doing my whole career. I worked at a variety of observability companies, and I ended up at Hydraulics because the problems that we're solving were problems I was seeing across the industry and at the other companies I was working at. So just having really large volumes of data coming in more and more rapidly. I've held a variety of positions across engineering, product, and pre-sales. And also do quite a bit of hands-on work.
Fabulous. Coralie, why don't you follow up? Tell us a bit about your background.
Sure. Thank you very much. Hey, everyone. I'm Coralie Suzure. I'm a solutions engineer at Hydraulics. I'm based out of London in the UK. And my job is basically to understand business challenges faced by companies and help them get the maximum value out of their data using Hydraulics. My background is in edge services, CDN technologies, WAF, where I've supported dozens of companies during their migrations between providers, optimization of their configurations. And I joined Hydraulics because I've seen all those challenges during migrations and that my customers faced. And I would have loved to be able to use such a tool like Hydraulics to help me with that. So I'm really excited to be here. Thank you for having us today.
Oh, I'm so excited to get into it with both of you. Thank you again for being here. Why don't we go ahead and dive into our topic focus, which is, of course, is data silos. So tell me, why are data silos so painful? And what kind of symptoms might you experience if you do indeed have data silos? Catherine, I imagine this is something that hopefully everybody could tell that they have it before somebody has to break that news for them. But tell me about that. What can they do if they are experiencing those symptoms?
So typically it happened, the end result is that you can't act quickly. So the symptoms are typically you have data in a variety of places. You have to use different languages to access that data or different tools to access that data. Even within a single system, you can still have data silos. So you can have data that's spread across a variety of tables because they have different structure. And basically what happens in that situation is you end up having to do a lot of correlation yourself, sometimes visually, sometimes with other tools. And you're typically making hard choices about what data you're going to use because it's hard to pull all of it together. The specific problems that you'll end up having are like, it's really hard to get to root cause. What is happening? Why is it happening? And more importantly, how do you mitigate the problem that's happening in real time? So if you are having, if we talk about Super Bowl, a live event stream, I think there have been some good examples in the past year of live event streams that did not go well. Don't want to call anyone out, but if you can't fix it in the moment, you're impacting customer experience. So companies get really concerned about how do I reputationally keep myself in positive standing with my customers. And that typically means like if problems are arising, you either want to see them before your customer notices them, or if they do, you want to mitigate them as quickly as possible. When we're talking about something like CDN, that also means the data can be in a variety of formats. All of the CDNs send different data. They call the fields different names. So things like client IP would have a different name across different sources. They also send data in different units. So where someone's measuring response time in milliseconds, someone else is measuring response time in seconds. And so while those all seem really trivial, it matters in getting real information out of the data because you still have to analyze it. You want to be able to do analytics across all of that. So if I have, let's say, 3 CDNs and I have the data siloed, I can't look at response time, for example, overall. I can look at, average or P99 response time across the individual silos, but I can't do an aggregation and look at that data as a whole unit and understand what's the, typical response time across all of my viewers. It would be in silos across those. So you could still get like, what's the P99 across this CDN, this CDN, this CDN, but not across all of them together.
Really makes you wonder whether or not the Academy Awards was measured in seconds or milliseconds. I certainly wondered about that. Sorry, Coralie, please continue.
No worries. Thank you. You really highlighted here, Catherine, the multi-CDN silos, and we are talking here about one nature of data, right? We are only talking about CDN data, but there is another type of silos, which is the CDN versus security silos. So most organizations have their security teams and CDN ops teams working separately and looking at different type of data and completely different pieces of their platform puzzle, right? So security teams' main goal would be to block malicious traffic. So for this, they will optimize their WAF rules, configure their bot management tools, rate limiting, etc. CDN teams, on the other hand, will focus more on performance and user experience, tweaking their CDN configuration for that. But neither team can see how their changes is actually impacting the other's objective. And this creates scenarios where, maybe a security rule is actually causing performance issues in the background, blocking legitimate traffic in specific countries due to a specific rule, or directly hurting the customer experience, blocking, a specific path that shouldn't be, and causing users to drop off and this reputation to be hurt in the end. So it's really having, again, this global visibility that Catherine, you were talking about, not only across, one part of the data, but across the whole platform, and having end-to-end from the edge all the way to the origin, to give you visibility onto the experience that your users are getting and to optimize your platform end-to-end. And again, it's almost impossible when the different teams are storing their data in different tools, looking at their data in different tools as well, in different dashboards, probably sampling their data at different rates, having different retention periods. And when an incident happens, or a ticket is filed, a customer is complaining, you don't have this end-to-end visibility. You just have the teams that are working in parallel, looking at completely different pieces. And therefore, the mean time to resolution can skyrocket because teams might argue over the root cause, and it's not their fault. They are looking at completely different data, showing them completely different things. So they are really focusing on what they can see and finding the root cause and sometimes fighting instead of working together, collaborating on solutions. And this might be, you know, one of the consequences. And this is what at Hydraulics we've been trying to solve, really trying to build this overlay between CDN, security, and other data to show really real-time correlation between all that type of data to show the complete journey of one specific request.
Thank you so much for that, Coralie. Let's dive into one of your biggest successes of the year over at Hydraulics, and that, of course, is the Super Bowl. It's, of course, the most watched event in U.S. sports, and Hydraulics was the observability provider for Fox. Small potatoes? No, very exciting stuff. So what kind of data goes into an event like this, and how do you prepare for the big day?
We actually have a slide with some numbers on it that I'd like to start with, because I think it shows the scale of what we had to do. So you don't know how many viewers you're going to have, right? There is a lot of prep up front for us from the Fox team of, you know, it really depends on what's going to happen with the game. Like, where's the game at halftime? You know, is there any major turnover in the game? And so we had to be prepared for kind of anything. And the reality of what we had an ingest rate of over 17 gig a second. That's 55 billion records that came in, individual log lines. And those were about the streams that were being watched. So every person watching the stream, every segment that was downloaded, we were getting an individual entry for those. From the time we got the data, we had a 5 to 10 second time to glass, meaning that we ingested it and it was queryable within that time, which includes doing a bunch of transformation and enrichment on the data. During the event, there were about 55,000 queries over the course of the event, with less than a half a second query response time, which is, you know, pretty phenomenal at this scale of data. Over the entire event, we ingested about 200 terabytes of log data. So that's just in a few hours. The figuring out how to do this is, there's a lot of testing, but you can't actually test the event. You're not in it. Like, you don't know what's going to happen until it happens. So to prepare for this, there were a couple of playoff games that we used. So we could extrapolate from that, like, what do we think the scale is going to be? How much do we think we're going to get? The second thing is figuring out, is your data right? So, you know, we're ingesting from all of these different sources. How do we validate that, yes, the data that we ingested matches what the, you know, whichever log vendor was sending to us? How do we measure that that's right? And so we had to go through quite a bit after those test events to look at, okay, does this match? Did we ingest everything? Are we using the right fields for the right measurements? Because like I said earlier, the vendors all use like different naming conventions for things and, you know, send different types of data. So we had to come to a common understanding of things like latency and throughput. Each vendor measures those a little bit different. And there were even, like, during the game, there was, you know, one vendor who was like, I don't think that we calculated that correct, because they were looking at, you know, how they were performing compared to other vendors. Another thing is we optimize for query at a smaller scale. So one of the challenges with data at this scale is there's a finite amount of compute available for query. So at this scale, you simply can't do the same types of queries that you do at a lower scale. So, you know, one of the things that we had happen was during the second playoff game, the data changed dramatically. One of the fields that we were receiving had changed dramatically, which really impacted our ability to query. We could still query, but it had an impact on how the data was being analyzed. So we made adjustments to accommodate for that. But really what we like to do is process the data as much as we can on ingestion, so that when you go to query, the query is as fast as possible. And it's just the nature of having really large data. In order to efficiently use it, you do have to have some structure to it. And then we had to determine also how we wanted to use all the compute. So at this scale, cloud providers don't necessarily have the compute available to do all of this. So we had to look at what we thought was going to happen. We were ready for 3x the scale, but the cloud provider didn't necessarily have all that available in one region. So we had to look at our overall architecture to understand, can we split this across regions? How can we divide up the cluster? We're still acting as one in order to accommodate that scale. So we ended up going with a multi-region deployment where the data was being ingested across a variety of regions, but it was still going into the same place, and we were able to query it as a single thing. So it's a lot of, get to the scale of testing as much as you can, and then extrapolate and make some educated assumptions about how the event will go.
Coralie, is there a UK equivalent you might be able to give us an example about?
Yes, absolutely. So, Catherine, you mentioned the harmonization of the concepts and the data across the CDNs, and I guess this is the pain that every single streaming platform will be facing. And indeed, Katie, we worked with the Zone during the FIFA Club World Cup last summer. And they were also ingesting multiple CDN data into hydraulics. And one challenge that was highlighted in preparation of this event, and again, I believe this is all streaming platforms are facing this issue, especially as they are using multiple CDNs, is the different tokenizations mechanisms between the CDNs. So some CDNs might be basing their tokenization on JWT tokens, some others on cookies, query strings, and others differently. And it becomes really difficult to build the rest of the logic around those different tokenizations to, tackle piracy and things like this, because you have so many different parameters to take into considerations. And it's really, really easy to miss something. So having harmonized visibility across the CDNs on what requests are authorized or not is very important, so that you can have, one unique dashboard with all requests denied in red, all the allowed one in green, with the different reasons why they are denied or allowed across all CDNs. And of course, you can have elaborate filters on any parameter you'd like, ASNs, country, and things like this, so that it allows to pinpoint issues in this logic very, very quick, because you're able to filter, and again, you have visibility onto one single dashboard, and all this can be done very precisely when ingesting 100% of the data in real time. So that was one of the items that we worked on during the preparation of this event with the Zone. And another point that was really interesting with the Zone, and I guess for, again, all that type of events, is you have so many teams working together. So it's all about bringing everyone together and providing the same level of visibility to everybody. So the Zone, for example, they have a CDN team, but also a piracy team and a team in charge of ads, for example. And as the CDN is at the end of the chain, they are often asked first when an issue is happening, and it's very important for them to have visibility so that they can answer their colleagues. And having the data at hand really facilitated the collaboration between the CDN team and the ads team on one of the games, because the CDN team was able to detect an issue on ads thanks to a dashboard that was filtering on specific content type, in this case, the ads. And there was just an increased latency on ad playback during the peak concurrency times. And thanks to all those dashboards that we built together with the DAZN team, they were able to identify the root cause, which was just a bottleneck at the ad's origin, and this very, very quickly. So ultimately, we helped them get visibility onto the data, but the DAZN team knew from the beginning what they needed. They knew the value of having all this data. They knew the value of having end-to-end visibility, and we just supported them and showed them how to make it easy to use. That was just it during this event. And again, when I say making it easy to use, it's not only easy to read, it's also easy, operationally to be alerted when something is happening. So their teams don't have to be glued to the dashboards all day. We know that during those events, such as the Super Bowl or that kind of big events, everyone is eyes on the prize, and we have the resources that are here to act fast. But it's also important to have alerts that can alert your different teams in case of something happening, because you can't see everything, right? And alert the right people, get notified on tools that you are used to use. So different tools that are integrated by default. So Slack, PagerDuty, Jira, whatever you'd like. And it's really this proactive approach that makes all the difference when you're dealing with such important events, but also smaller events where you are more allowed to take a breath. But you still need to have your platform up and running, and having those alerts can make the difference.
It's just an incredible amount of preparation that goes into these massive streaming events that happen all around the globe. And what I'm thinking about is how you're even able to prepare for when things are not going to go according to plan, and how you prep for that with other events, as you mentioned, Catherine, that you also don't know how to plan for. So it's incredible the way that you stay flexible and can pivot. But we have to be honest, though, not everybody's big event is going to be the literal Super Bowl. There are still events that are going to happen at maybe a smaller scale, but are just as important to those businesses and companies. What other strategies for scaling monitoring across complex multi-service environments can you provide? And how can our listeners apply them to their own systems? And Coralie, I'll put that over to you to get us started on this one.
Yes, for sure. So yeah, definitely. So not everyone is streaming the Super Bowl, but every business has their make or break moment, I guess. So if you take gaming studios with their big game releases, gamers want those downloads fast, right? And any failure in the infrastructure can spread across social media within minutes and do some reputational damage. So those are the kind of events that you want to prepare for, and it's more or less the same strategy, aligning everyone, giving visibility end to end, and just aligning everyone. For retailers, take Black Friday, for example. It's coming up soon, and it's a critical time for them. We are talking about scenarios where if you have a few seconds of downtime, retailers can lose a big amount in revenue, and slow platform can kill conversion rates, literally. So the challenge is that they need their infrastructure and configurations completely optimized, and ideally, to have that, they could build on historical data from the previous year, for example. But for this, we realized, and with talking to different customers, that with traditional platforms, it's really difficult to be able to keep this data for that long because it can become costly. And you know that when you're running such events like Black Friday, you can have recurring attacks that are coming from one year to another, and having this data from the previous year could be very, very, very important. And again, it's all about having real-time visibility on the day as well, to ensure that the time to detection of any issue is super low, but also having the full data to allow to your teams to investigate super fast and precisely and lower the time to resolution as well. So, for example, if we take a typical scenario, a typical Black Friday scenario, Black Friday campaign launches at midnight, and it makes retailers way more vulnerable to attacks, because this is where they can hurt the companies the most, right? And if an attack is happening, legitimate customers could face slow load times or service outages during peak shopping hours, and it's directly impacting the revenue during those critical hours of sale window. So Hydraulics here allows to surface any bandwidth spike, for example, having set up alerts based on this, and especially triggering alerts on bandwidth spikes coming from requests from non-user agents, geographic clustering of suspicious clusters and suspicious geographies, and giving really visibility into the source of the attack, and then it allows, so automatically you get the alert, your teams are alerted, and it's immediate. You don't have to have your eyes on the dashboards, and ultimately your teams can enable the WAF rules that they have to rate limit all the IPs that are at stake, and anything that they have to do. So it's, again, having all this data allows you to have visibility, but also be alerted rightly at the right time based on the right parameters. And when I was talking about detecting an attack and making the difference between an attacker versus a legitimate user, it might not be that easy, and as easy as, yes, user agent and that's it, right? There are so many parameters nowadays that attackers are bringing up and to take into consideration to detect an attacker from a real user. It could be, often attackers are just bots, right? So it could be session duration, sequence of interactions on the website, for example. And we are not talking here request per request. We have to take a full load of requests from a specific session to define patterns that would correspond to real users versus patterns that would correspond to bots or attackers. And this is where it becomes tricky for the human brain, right? Because putting together all those parameters is very difficult. And when you have 100% of this data, well, you can use it to train machine learning models that will combine all those parameters for us. And this is why we have developed a connector with Spark and with Databricks, so that you can use Hydraulics as the source of training for your machine learning algorithms. And we even went a little bit further because we have created our own MCP server. So an MCP server is a program that allows to interact with external systems using a universal protocol. So MCP is the short for Model Context Protocol. And basically, in the case of hydraulics, it's the bridge between the hydraulics database and the LLM of your choice. So you will be able to start asking in plain English or plain French, if you'd like, show me all the traffic from the users that had unusual click patterns in the last hour. And it will translate into SQL queries, run them, get back the data, and provide you back with human readable insights. And again, this is using the whole database that you have in hydraulics. And what I love about this is that it completely changes the game for business stakeholders, right? Because they don't need to go to their technical teams so that they can run complex database queries. They can just ask questions as if they were talking to their colleague. And it really bridges this gap between the technical teams who understand the data structure and the background, and the business teams who need to make decisions based on this data. So I can even show you what it looks like, so that you have an idea of this. So let's say, so again, we need to do a little bit of prompt engineering here. So here I am asking Claude. This is the tool that I'm using to communicate with the database. As a streaming analytics expert, please use MCP to analyze our current streaming performance data and provide data-driven recommendations for preparing the infrastructure for a major sporting live event like next year's FIFA World Cup. And then when I run that, it will start to query the database. So you can see that I'm not touching anything. It's looking into the hydraulics database. So it starts by looking up all the projects that my user has the right to access. So you can see here that we have an IBC database. This is the database where we have our demo data and that we used for IBC in this case. And it's listing all the different tables that are there. And if you open the different parts here, you can see the different requests that are being run and the thought process as well, which is very interesting. And in this case, you can see that, okay, great, it found the tables that it's interested in. Awesome. It looks like we have AWS CloudFront data, we have CMCD data. That's awesome. Let's dig into this. And then we run different type of queries. Again, seeing, if we can see any specific improvements, geographic performance, anything specific here. And you can see here that we had a specific error on a query, and it's automatically fixing it as well. So it's also learning based on this specific prompt. It's also learning to rectify and to get better in terms of querying later. So here it's nothing to do again. It runs a bunch of different queries here, so that it will get back to you with the different insights and different recommendations around the data. And I can show you the results of this because I ran it before. So you will be able to have, in the end, a specific document that is produced for you. So not only it gives you, the key findings in pure English, right? So it seems that we have great cache hit ratio, that's awesome. Time to first byte doesn't look too bad either. But you have also critical actions to perform here, it seems, and some things to fix. And it produces you a document, and again, this is a document that could be a PDF, for example, for executive use. And it tells you what are the critical issues where you need immediate action. With, in this case, there are some POPs that are not behaving very, very well. So something to improve here, some geographic performance as well to improve, and some recommendations around how to prepare for the FIFA World Cup. And you can see how powerful this is because, again, it took literally 2 minutes for it to get back with that. And it's analyzing a huge load of data. So with a little bit of prompt engineering, it can be very, very powerful for different teams.
Thank you so much for that demonstration, Coralie. That was so exciting to see. And before we get to our Q&A section, I just want to check in with you, Catherine. Anything you'd like to add on top of what we just spoke about?
Yeah, I think that beyond retail, gaming, live streaming, every industry has its big events. So if you think about the transportation industry, there are big holidays where folks are traveling, tickets go on sale. There are really large countrywide events in places like China and India where like everybody's traveling at once. And so you want to make sure that those systems are operating so everybody gets where they need to go without any problems. In financial services, if you think about payday, right? Everybody wants to log in and see their pay stub, understand that their deposits were all made. And this isn't about the financial transactions on the back end. It's more about the user interacting with the data and how that's working. So we've seen a couple of times where a customer who isn't really a traditional CDN customer, where they have content that's cached, using CDN logs as like a really strong signal for the customer experience. And so while they're not a streamer, they're not doing ticketing or anything like that, they still want to make sure that their users are having good experience. And the CDN logs are right at the edge, or as close to the user as you can get without actually gathering information directly from the user's browser. And so you can see really quickly what their experience is, and then you can go dig into your application logs, your database logs to go then mitigate any of those issues.
Very well put, and thank you so much. Let's move on to some questions from the audience. We already have a few to dig into, so I'll start with this one. Very basic, very forward. How hard is it to adopt hydraulics?
I can take that. It's really pretty straightforward. Our approach as a company is to integrate with the tools that you have. We know that you have observability solutions. We know that you already have dashboards built out in those solutions. And so a lot of our focus has been on integrating into those things. So we've released things like a Databricks Spark connector. You can query the data from Splunk as well. You can query the data from Kibana if you're an Elastic user. So we're really trying to get the data to where you're already using data so that you can bring those things together.
Excellent points there, Catherine. Let's go on to another one. What makes hydraulics different from traditional log storage?
You want to grab that, Coralie?
I can take this one. Yes. So hydraulics has really been created with the scale in mind, right? It was really created because, companies realized that ingesting their billions of CDN logs was not financially possible, and also the traditional solutions was just not able to scale to receive this amount of data that suddenly, right? So I would say that we really created, and when I say we, our founders created Hydraulics with the scale in mind. We are based on the cloud, right? So and we are based on Kubernetes. So as long as you have a Kubernetes environment, we can deploy the solution, and we really use the advantage of those hyperscalers, right, to scale up and down automatically. And what is great with Hydraulics is that the architecture is completely decoupled. So it means that we are scaling up and down the services that you need at the right time when you need them. So let's say you have a spike of data, of requests generating a lot of logs at a certain point in time. Well, the ingest part of the infrastructure will scale up, but the rest doesn't necessarily need to scale up as well. And vice versa, if your data scientists are querying historical data and a big amount of data, well, we will scale up this side of the house while the ingest can stay as is and regular. So it really allows us to be efficient and cost efficient, because we are putting the right resources, the right compute resources at the right time, at the right place. And we are also using commodity object store as the storage. And because of the way that we ingest the data, we index it, compress it, and push the data partitions to commodity object store, we make this commodity object store, which is, let's be honest, cheap storage, right? It's really cost-effective storage. We make it efficient, and we make it performant so that it can be considered as hot storage. So yeah, that's a little bit. And again, Hydraulics is different in so many different ways from the different other platforms. But yeah, that's for me.
And if I could just add on to that, something that we do that's really unique is we don't compress the data once. We continually optimize that. And so that's how we get really amazing compression. We're not just doing it once, we're doing it multiple times. But what that allows you to do is, going back to Coralie's demo, if you're running an event next year, a lot of systems have limited data retention. So if it's been a year or 4 years in the case of some sporting events, you really need that data to do that analysis to understand, okay, well, what happened last time? How do we extrapolate that into what's going to happen this time? And we can do that because we do make it incredibly cost efficient to store that data for long periods of time, because we can get 10x reduction, sometimes even greater, depending on the data set in the data, so you can store it. And just to emphasize what Coralie said, it's always hot. The path to read the data is always the same. We don't have a tiered storage like hot, warm, cold. So if you're querying data from an hour ago versus that same hour a year ago, the performance is exactly the same. We're not going through different paths or different storage mechanisms to get at that data.
A great add-on there. Thank you so much for that, Catherine. Let's go on to this one, and this is particularly timely in today's market. What's the impact of your product on AI and ML initiatives?
So I can jump in on that. For AI and ML initiatives, the biggest issue in many cases is data. And it's not just about having examples of things that went wrong. You need examples of things that went well too, in order to come up with really good models. And so by being able to capture all of that data and keep it for extended periods of time, you can get better results out of those initiatives, because you have more examples, you have more to pull from in order to see, again, not just what went wrong, but what went right as well.
And if I can add to this as well, it's, you know, the more data you have and the better your models are trained, that's for sure. But also you need quality data, right? And the fact that we are able to harmonize the data on ingest with hydraulics, you know, creating one single table and harmony between the data, and enriching also the data thanks to hydraulics on ingest. Well, the quality of the data ultimately that you will train your model on will be way better, and therefore, yeah, produce better results.
Excellent, excellent. Let's move on to another. We have time for a couple more. How long does hydraulics keep your data hot? And what is the limit on data stored?
It's hot forever, as long as you keep it. Like I said earlier, it's the path is always the same. We don't have a concept of tiered storage. Our default storage is 15 months, but you can set that to be really anything you want. And it should be based on how long is that data relevant to you. So, you know, there are things that only happen once every 4 years or once every 2 years that are important to go back and look at. And so you can also decide based on the data how long you want to retain it. So we have customers who will take data from particular events that are really important to them and store that data longer than they do, you know, data from the same data stream that wasn't during the event. So there's a wide variety, but our customers, you know, one of the reasons that they choose us is because of that long retention, and the long retention is a result of our ability to store the data efficiently.
Yeah. And if I can add to this as well, in Europe, we see a lot of customers that have to keep their data for years for compliance reasons. And this has been a big problem for them until they knew hydraulics. So again, a lot of customers in Europe keep their data for a few years.
Absolutely, I can understand that. Let's go on to one more question before we close out today. When engineers are troubleshooting or investigating an issue, what do they actually need from a log platform to be effective?
I can go ahead and take that. You need needs to be fast. If you're gonna go for a coffee break and come back to get your answer, that's not effective. You need to have all the data to answer your question also. So that doesn't just mean longevity, but Coralie had mentioned earlier, some people do sampling in order to fit the data into the containers that they have available. So if you don't have the data and you don't have the speed, you typically can't answer those questions. So you need some flexibility. And then additionally, you know, additions like MCP and the ability to do natural language query, and not just natural language query, but get results back in natural language, really speeds up your ability to be effective. I'll pass it to Coralie, see if she has anything to add.
Yeah, I love those 3 points. I would say as well, flexibility, and I mean it's linked to MCP, but in the way that you visualize the data and not being locked in a specific types of dashboards or something that you're not familiar with. So having this flexibility in the tool that you're using to query the data is very important. And also, what I would say is when you start ingesting your data into hydraulics, you can build on the experience that we have had with different customers like Fox, for example, or others from different industries, because we've built those visualizations that can be reused by new customers. So it's also, you know, ease of use and not having to straight away dive into a database that has 1,000 fields and that, you know, is tricky to understand and to manage and to handle and understand completely. So building on suppliers that have had this experience before and providing already, you know, visualizations that will help you understand the data easily is something that counts as well.
For sure. We did have one more question sneak in at the buzzer, so we do have time to answer it if you're comfortable. And this one's interesting. How much does hydraulics cost compared to other vendors? What's the cost comparison when comparing those solutions?
We actually have a page on our website that helps address this. It's hard to say specifically. Like in tech, it's always, it depends.
Right.
However, our cost is our cost of storage, which is typically the largest piece of any platform like this, is based on consumption-based storage. So we use object storage. You get charged on object storage based on how much you're using, not how much you provisioned for the system. So a lot of other platforms like this, you have to provision the storage ahead of time. You may or may not use it. And for us, we're really relying on object storage. So it really comes down to the cost of the storage. We use cheap commodity object storage, rely on it for its durability, availability, persistence, all of that. So not to not answer the question, but if you take the root cost, which is the thing that typically costs the most, is storage. Ours is significantly less because of our model of how we store things.
Excellent. Excellent. Well, thank you both so much. That's all the time we have for questions today. But to the audience watching, don't worry if you still want to sneak in a question and we didn't get to it or won't be able to get to it, someone from the team will reach out after the event. And as we wrap up, I'd like to highlight what you can take away from today's presentation. The same strategies that kept millions of Super Bowl viewers streaming without a hitch aren't limited to one high-profile broadcast. These are lessons any organization can apply to eliminate blind spots, improve collaboration, and deliver stronger digital experiences. Breaking down silos isn't just about sports. It's about creating resilient systems that help teams move faster, perform better, no matter the challenge. Before we close, Catherine, Coralie, where can those who are watching go to learn more about hydraulics and the work that you're doing?
Our website, so hydraulics.io. So the spellings are on the screen, HYDROLIX. It's not hydraulics, it's hydraulics. And it's .io because we are a data company.
Amazing. Thank you so much. And thank you again for joining me today, Catherine and Coralie. I appreciate your time. And to our audience, thank you so much for watching and joining us today. We hope you found today's session both valuable and inspiring. If you'd like more information, don't hesitate to reach out to Catherine, Coralie, or their team at Team Hydraulics. Once again, I'm Katie Bavoso on behalf of D-Zone. Have a great day, and thanks again for joining us.